Hello and welcome back. Today I'm going to have a last look at this Juntek. I tried to make external reference last time, and after I did that worked, but it was still not that precise. So I'm going to have a final look if I maybe missed something, or maybe there is a second oscillator. Oscillator is super small, and I thought, yeah, maybe I missed a spot, and maybe the point where because yeah, it's very small. I will put a microscope. The oscillator is like 5 mils. I think 5 by 7 mils or even less. Um, that I maybe missed a spot because I cut it in a resistor that goes to the FPGA, and I thought that would be it now. I removed the resistor, put my switch there, exactly what I did with Tech, where it worked perfectly. But maybe I thought there is another track or a second oscillator. Well, I can't see it in the top of the board, so maybe at the bottom. So I will try to find if I can see something there. So I'm going to have a look in the microscope. Well, the oscillator is very small. Here it is. And as you can see, now you can read, it's 50 megahertz, and it really seems like, well, I'm sure, let me get a pen, I'm sure this is the output right here. And it really looks like there is only one track going here. But maybe if it is a multi-layer, there is also something connected from the bottom, or because I'm really cutting it here, and then if this is the only oscillator, this should be enough. I already measured here, here, and here, and I didn't find any signal. Well, this one is clearly power because of the resistor here and the cap. But yeah, I need to see if this is not the only track. So maybe there is going also a track to the bottom. Okay, first some basic tests. Do I have output? It's switched to internal reference, so it should function as normal. So when I switch it on with the oscilloscope here, I look on the output, I should see a signal. I have signal. If I switch it over to external ref and external ref is not connected, probably crashes. But I also have no output. Makes sense. But is that the same for the frequency counter? Because the frequency counter was also off. So first back to normal. Do we have output? Yes, okay. Then I'm going to get 10 megahertz. I go to input, measure. Okay, now my external is frequency counter. Let's get 10 megahertz. Well, it is again those 72 hertz off. Let's do the same without. It stops immediately measuring. So that seems to me, okay, so there is no extra oscillator. Yeah, still I'm going to have a look. Otherwise it is just what it is. I can close it, I can put it properly there, but it's a pity. Well, I already had my solder iron here, but I probably don't need it. But I did clean it, and I'm not sure it's the first time in 25 years, but this is not something I clean all my devices, but I forgot that it's like new. This is some good quality, the Weller. So I put it away, that's why it's here. And it's immediately like new, but it's just a tool you forget to clean sometimes, just like you're not always cleaning all your pliers all the time. So let's open this. I think is, well, all the plugs have a different size. Well, let me zoom in a bit more. Okay. Yeah, there are screws in the bottom. Two little ones in the front. Then we have plugs. They all have a different size, so I can just pull them. Well, that is it, I think. I should be able to pull it forward. Yes, I am. Okay. Well, here is a little processor, but that is, of course, just for the display. I like its size because the field tech is a little bit too small. Yeah. Let's see if we can have a little look at the board. This is loose, this is loose. Then I can make this. And this can just go out maybe. Oh, let's have a quick look. I'm not really good at this, but I should use. I always forget. I remember when I work in Honeywell, when you come in, you need to check every day. If there is no, you check your cable. Special machine, it will beep if the resistance is not good. And here I just forget all the time. I think I will unscrew also that. Because I put the extra switches and everything on the back, it's kind of all connected. So maybe I need to take the board, including the, yeah. No oscillators in the back. Let me check if that, no, that doesn't seem to be a, where's the oscillator exactly? Right there. Doesn't seem. I will put this back together. Well, I'm looking at my old video and it really is just one track. I don't see there is another track going to the bottom or somewhere else. So this is probably really the only thing we can do. There is really just one track directly going here to this resistor that we remove, and we inject the external signal here. So yeah, I will close it up. So that does look a lot better. It is here. Well, we improve it only a little bit with external reference, but we already did that last time. I just wanted to do a check if we could improve on that, but apparently we cannot. I don't want to do another big project because it's a little bit my lazy Saturday. But what I'm going to do is I also have this Riden here, and it still needs to have a PWM controller. And I already made something else you can also see in the other video. But I really want to go back to the PWM. And the fan is 24 volts, but it actually runs on 29, and that's why it was so loud. But it also means I cannot use a 24 PWM controller. So I found another one, that is this one. And this one can go up to 48 volts. So with this one you are safe. And it has a temperature one. And it will just make the fan run very slow, up to 30 degrees Celsius, and then it will just go up. I don't know the exact temperatures, but this is really made for fan control, so it will absolutely try to get it, I would think, below 70. But it will already start increasing the speed above the 30 degrees. I don't know the exact specifications, but yeah, it seems a lot better than I did before. Also, in my other Arduino project, I was trying to make from start to finish. So it's nice if you also want to play with the Arduinos and you want to know exactly from the start, from the software to install everything. And then I was fighting with my subscriber counter because you needed the Google API and also the internet. I just couldn't get the internet running. But I found a guy, Carl. I will link also to his channel, and he made it work. You need to install an older version of the JSON, and I did that. So, but then it works. And he also changed a bit the code, and then you are able to use a double screen. So I will play with it later because, yeah, it is not that complicated. Now I know how that works. Oh, I did find a bit more about the fan control. When the temperature is lower than 30 degrees, and you can customize the temperature, but it doesn't say how, it will stop running. When it's higher, it will start at low speed. And when the temperature continues to rise up to 50 degrees, then the fan becomes in full speed. So it's doing the PWM really between 30 and 50 degrees in Celsius. There also is a buzzer alarm. When the temperature goes above 55, then the buzzer goes off. But I didn't install the buzzer, I see. But I do see the transistor that's connected to it. So if I have a little buzzer, I can still connect that. Okay, well, it's now Sunday. It was really lazy. So I'm gonna put now this PWM controller. It goes from 12 up to 48 volts, and it just yeah, puts out what you put in. So if you put 29 volts of this ventilator, if you put it in, it will, in the maximum settings, will just do that 29 volts. So this is really versatile. Just anything between 12 and 48. Safe choice. And it can do 3 amps per channel, and it has 2 channels, so you can do a total of 6 amps on fans. So if you're really a big fan of fans, you can put 6 or 7 or 8, and it can still control by this thing. So that's nice. I will just be using the first channel, and I hope the temperature sensor is the same as the sensor I already have, because then I don't need to open it. I can just replace them. So I will just measure the resistance, and but first we open. So let's see. The other time I really made a complicated system because I didn't have PWM. Well, I had for 12 volts, and then I thought maybe okay, I buy for 24 volts, but that was not possible because the fan was actually up to 29 volts. And I look at the regulator on the 24 board, and it really was up to 25 or 26, but not 29. So I didn't want to risk it. And that's why in the end I choose for this 48 volts. And then we are pretty sure it's enough. And what I did here, I think I took a little variable buck controller to set the ventilator in the lower speed. And then above certain temperature, I think 45 degrees that I set on my thermostat, then it would go full power. But of course it's nicer if you can use the PWM. That is what I'm going to do today, and make the whole circuit less complicated. Well, let me zoom in on what I did. So this is what I did. Here is a little buck converter. I don't know, I set it to 5, 6, 7 volts, very low, that the fan is just running at low speed. And then if it becomes above a certain speed, this thermostat will be switched on. So if I switch it on right now, you almost hear nothing, and the speed is in very, very low speed. And that is controlled by this one, the buck controller. And well, here you see now it is like 24, almost 25 degrees, and it's already cooling down because the ventilator is running. But then when the power supply becomes hot, this relay will switch on, and then it will run on full power. So now there is only two settings: very low silent or very loud full power. And these little circuits I will now replace with this one. Well, first I like to see if the temperature sensor is the same, because then I don't need to open the whole power supply. So let's have a look at that. Yes, I think they are, because there's the same connector. And yeah, why would you change this? Make a lot of different sensors. So if I measure this one on this temperature, it is 477. How much is this one? Well, I probably need to take it out of the board, because let me measure this one again. $933. Okay. $10K. Okay, they are a little bit different. I'm surprised. They are all different. Okay, well, then I also replace the sensor. I need to reopen the whole power supply. Okay. Okay, I removed all the old connections, so it's actually not that complicated. This is the temperature sensor. That is with this metal tape that is used in the heating industry. It can withstand high temperatures because it is made for exhaust of your combi heater. I use this to fix the sensor to the heatsink. That's a good tip. And so the sensor just goes where it needs to go. And maybe I can zoom in a little bit more on the board. But this is where the ventilator was connected to. So this is the 29 volts out from the power supply. And this is, I made a little extension. This is the ventilator itself. So it's just power in and fan speed out. I see if I can zoom in a bit. Okay, here we have it. Well, as you can see, this is just V in plus. Let me put some shadow. V in plus, V min out. It's really difficult to see the. Here, now it's better. Plus in, minus in, fan plus, fan minus, fan 2 plus, fan min. So we only need to use the first two. So okay, so it's first it's plus in. Okay, minus in. Okay. Then it is fan out plus. Fan out min. Okay, then we have the fan out 2 we don't use, so I will screw the screws. Then we have some PWM export output. We are not using that, so it broke already. That is not good. Okay, let's see what it does. Hopefully it doesn't make a huge noise on the lower setting. No, it doesn't, so that is good. The light is on. Okay, let's see if we can play a little bit with the other temperature sensor. Off, because I didn't do any testing at all. So what if we put this sensor and then we can heat it a bit with the iron. So we switch it on. Indeed, nothing is there. Now it starts heating. At some point the ventilator should switch on. Yeah, here it goes. Oh, nicely. It accelerates slowly, more and more and more. We make it even hotter. That is very nice. Okay, let me try to cool it down. Compressed gas, but if you put it upside down, you have a coolant. So. And it's back to silent. Cool, perfect. Okay, I put a lot of tape again because I am too lazy today to properly screw it to the plate, but this works. It is stuck. It fits exactly. If you look past it, it will fit. So this is it. Completely silent. I had a question of one of the viewers, Audio Vintage, and he wanted to know how much is the rimple. So what I'm trying to do is I will just put a load. I have here 4 times 10 ohms. I switched everything on, so that's 2.5 ohms. And then I have all my power in parallel, so I think how many watts they are. I think they were like 50 watts or something. So then we have 200 watts. I have an older probe because it could melt, because it's going to be hot. I connected to my load. I specifically want an analog or a pure resistor load. So if I have a distortion, it is purely what is from the power supply, because I do have an electronic load also, the Kunkin. But of course, you will also measure the distortion that the electronic load will do. So let's see if I do VSET. It is set to 20 volts. That will create some power. I forgot how it works, so of course you need to put the outputs on. It is now 7 amps, 150 watts. And how much distortion do we have? It's AC coupled, so we should be able to see something. Well, without anything connected, we already have like 10 millivolts. And now I connected without any load. And we already, well, we have pretty much, because it's 20 millivolts, so 20, 40, between 40 and 50 millivolts, and nothing is connected. Let me do a screenshot of that. Okay, now we put the power on. Boom. Okay, I made some screenshots. Now it's like almost 8 amps, 20 volts, 160 watts. And now it is like 350 millivolts of distortion. And now I want to raise the volume VSET. Let's do 30 volts. Let's see what happens then. Yeah, my resistors are a bit hot. Dat is beter. Okay. Let's see how much we have then. I'm gonna make it very short. 350 watts, 400 millivolts. Now, let me make 450 even. Okay. Now suddenly the ventilator switch is on in very low power. So it does work. And I don't mind if the power supply makes noise, because we were at how many watts? I don't remember, 500 or 600 watts, I think. So, okay, you can make a little bit noise now, but then afterwards you need to chill again. So now I put it to 40 volts and 18 amps. So that would be 800 watts, I think. Let's try. Let's see how much noise we produce then. Now 600. It goes 630 watts. And let me print. Okay. Also about 500 millivolts. It starts to be a lot. Let me do a little bit more voltage. 50 volts, 18 amps. Let's try what we have then. 825 watts, and the distortion is now more like 600. Print. Okay, switch off. Cool my resistors a bit. Yeah, my probe is melting. Well, that's why I took the older probe. Let's go to the full 1000 watts. VSET, I need to get used still to this one. 65 volts, no, 61 is the max by 18 amps. My resistors are still bloody hot. They didn't chill too much yet. Okay, well, let's do it very shortly and immediately print. Full power, no, 800 watts, it doesn't go very further. And how much are we here? Okay. Nope. My resistor smoked. Ooh. Well, clearly the resistors couldn't handle it, but we just calculated quickly that if we put this in parallel, we had 200 watts, and I'm testing with 800 watts, so of course that doesn't work too long, and this is the result. The resistors are completely melted. Oof, and the heatsink is also a little bit hot, of course, that was the whole point, and yeah, so having a resistor load for 800 watts can be a bit difficult to find. Well, while doing this load test, aside from burning my resistors, I also noticed that it is not blowing in the back, it is sucking in the back. So that means it sucks in cold air, and then the heat in the front here somehow needs to get out, and I don't like that. I want it to blow out the hot air, and automatically the cold air will come in. So I didn't notice that with my other modification, and I really want the fan to blow out the hot air in the back, because automatically the air will come in. So yeah, blowing in cold air is not the way I like to do things. So I will need to see if I need to. I will just well, I cannot change the positive and the negative on the control board, because of course the control board won't work. But I will change the fan. Or am I confused? No, it's really sucking. Yeah, no, that's not good. Well, good thing I did with tape, so I can easily switch that over. That's weird, because on the controller it really said plus and minus, but or it was designed to blow the other way, but that is really silly. You never blow in cold air. You usually blow out the hot. At least that is what I would do. So well, the fan doesn't want to blow backwards, so I'm just gonna open it again. I want not, because then cold air comes in, the hot air comes in, and then it's blowing hot air to all the electronics of the front. I don't want that. I want it to blow out the hot air, then the cold comes in, then this can cool, and it will just go like this. I don't like the design, or maybe I turned the fan myself backwards when I took it out the other time. Okay, I just flipped the ventilator over to see. Yeah, now it's blowing. That is so much better. You should always try to blow out the. Yeah, now it's blowing. So that was an easy fix. So now I'm going to play a little bit with the Arduino because that's just for me. I like that. Here I already have a subscriber counter, and it's with one display. But Carl made one. I will link to his channel with two. So I will be connecting these two together. It's the same. The code is a little bit different because it needs to scroll over more. So let me just try to connect these together. Now that is sweet. Yeah, that's good. Now I need to put my little VMOS, put the pins on there too. I will just do one and then I bend it in that. But it is a little bit small. Okay. That doesn't look good at all, but we can bend it. Well, one is good, the other one is not. No, that's good enough for me. Sort of straight. Yes, I should use a fan. I always forget. I have one. But I opened the window today, it's nice weather. Yes. Okay. Well, that's all the soldering we need to do. I was actually surprised how easy these Arduino things are. The design is super simple, and I will just copy what I did here. Of course, it's even more simple. No, I don't. There. Just like this one. Yeah. And then I need to connect the display. It's a huge one. Cool. Yeah. Okay, let me fire up the computer. First, I'm just gonna load the code that I did in the small one. Let me check what COM port we're dealing with because it's changing all the time. Okay, COM4, good. Arduino, sub counter, and I had the one from Carl. How I call this one from Carl? APV3. Oh, it was not Carl, it was Nico Props. Okay, that was fun. I had a nice weekend. Thank you for watching, and I hope to see you next time.